All right, let's start. Thanks everyone for coming to the last talk of the day. So all the survivors in here. I hope you really enjoyed the conference and taking something home to be able to improve your app. So today I'm going to talk about everyone's favorite topic, tech debt. So a bit about me. My name is Florian, and for the one who are courageous enough, this is also my family name. I'm based in Berlin, and I work currently at Qonto. I've been an engineer for the last 15 years, mainly working on Android. I worked at various agencies and companies on a lot of different projects. The common denominator of all my experiences, I mainly worked in what I call like small-ish teams, so ranging from like a couple of people to maybe 15, which is an interesting difference with Qonto, where we're quite a bit more. So speaking about Qonto, so Qonto is an app that's making day-to-day banking easier for SMEs and freelancers. We have a great online business account, as well as invoicing, bookkeeping, and spend management tools, and we have like awesome customer support as well. To give a bit of context on how we work at Qonto and the scale at which we are operating, we currently have, as of last week, I compiled the number there, we have 53 Android engineers and 10 leads. So for us, leads is like a technical manager that's managing the team. We have somewhat the same number on iOS, and all these people are split into cross-functional teams. We have 13 of them that are themselves split in 4 domains. So that gives you a bit of an idea of the scale. You would think that might start to be quite a lot just for an app, but we actually have a lot of different features. We're in 8 countries. You can experience the app differently if you are like a freelancer or if you are a different type of organization. We also have different type of memberships. So if you are an employee or a manager, or if you are the owner or an accountant, then you experience also the app differently. So if you multiply all of these aspects, you start to understand the scale of the work we're doing and the feature we are building. So a bit more context. So we are not a startup anymore, right? We're scaling up, but we're also not at the big tech level, which means that we are still slowly hitting scaling issues, but we don't really have as much resource as, let's say, Google or Facebook to just throw money and engineering at the problem. And at heart, we're also a product company first, so we want to deliver value for our clients. So what we do is basically be smart and carry on. So we have a lot of issue with scaling, but in this talk I will focus mainly on the tech debt one. I'll talk quickly about the problem. We'll just put yourself in the shoes of a new engineer starting at Qonto. So you start at Qonto, you are put in a cross-functional team, you start to familiarize yourself with the code base, you get used to how your team operates and your teammates, and you start shipping features with the right amount of speed and quality. And then, of course, because you're a good engineer and you like things to be clean, you clean up code as you go. But then soon you experience some problem, right? How do you know that the code your team owns is actually doing good, right? Or what are the most pressing issues to solve, right? Or even maybe your team is actually blocking an important migration, right? If you want to migrate from a framework to another, or if you want to stop using an API, you don't really have any idea of what is in your code and if this code is blocking. And usually the answer to this, right, is that I assume some of you also at your company use SonarQube is, well, all of this type of issue are on SonarQube, right? You go on SonarQube, you look, and you have this great number, you have 3,000 code smells. Awesome. And maybe you want to dig a bit more into it, and so you start clicking around, and you see, okay, I have 741 instances of this specific error. But then you don't really see if this error is in the code you own, right? So you might click more and try to click on the module you own and then try to dig in, but it's just very manual, error-prone, and it's just a mess. Like, you just don't do it. And so the consequences of this is that it's quite discouraging, right? How can you fix something you cannot really visualize? You know that your team's code has some depth, but you cannot really visualize it. And then the depth doesn't decrease, and worse, it increases slowly but surely. And then you end up with this endless discussion at weeklies on the state of the debt, right? Everyone is saying debt is going up, and everyone is saying we should fix it, but no one really is doing it, right? And you repeat this discussion every week. And so my point here, and the main point I want to make here, is that because the whole debt is everyone's problem, right? You have this magical number that is like, we have 3,000 issues in the code base, then it's also no one's problem, right? And so this is, up until not quite recently, this was the state of our debt, and we can see that the more we scale, the more we also get engineer, and the more we produce code, and the more debt we get. So here, the debt I'm mentioning is solely related to what the static analysis tools are reporting. We'll see later there's other type of debt that we also want to tackle. So how can we find and build a solution, right? How can we start to reduce this debt and tackle it? So first, we need to think about what we want. So in our case, what we want is, we want to improve the ownership of the debt, right? We want everyone to know, this is the debt I own, this is my debt, and this is what I'm supposed to be fixing and how I'm supposed to make the code of my team better. And to do this, you need to enable visualization and prioritization, right? So the team is to be able to improve the ownership of the debt, they need to be able to visualize it and to understand what is the most important thing to tackle first. And so, as a consequence of that, what we want, ideally, at the end, is to reduce the depth of the whole code base. But we also have constraints. I was mentioning we are quite big, but we are like not so big that we can throw 10 engineers for the next 6 months on the problem. So we started with the following constraint. We want to really have a cheap proof of concept, right? We don't want to go with like a null-out crazy solution we need to pay for. And we want to get a first version out fast to be able to validate if it works, if our engineers like it and use it. And we want to bring also some value straight away, right? The fear we had is that we were going to spend the next 6 months building some kind of like monster that when we release it, no one uses. And so the things we need to figure out before we start is the main topic is around the ownership. And for this, we already have a system in the app. So it's not like super crazy or very elevated, but we have, for each of our module, we have a README that gives us which team is the owner of this module. So we do have some kind of ownership per module, but we have two problems, right? We have 20% of our modules that don't have an owner. I mean, they actually have an owner in the README. It says Android team, which means that everyone is actually the owner of the module, so no one is. And we also have, at the time, we also had a big monolith that didn't have any owner, but contained 23% of the code base. And so we sat down and we realized that actually what we want with this solution here is to visualize the depth, but we don't want to specifically fix the ownership problem, which is a problem in itself, right? So it's not the goal of this initiative to fix every ownership issue. Let's just start with the ownership we have and then carry on. And then what we thought about that would be interesting as well is if we find a way to actually make the lack of ownership visible, to be able to say, here are all the modules that have no ownership whatsoever. The second bit is where do we get this data from, right? So as I was mentioning, we want to start with the output of our static analysis. So like most of you, I think we use detect rules, lint rules, and we also have quite some custom lint rules for like very specific issue we have in the Qonto code base. And we also want our solution to be that we can build on top and extend it so we can allow other types of depth. But where do we get this depth from, right? So option one would be to use some custom tooling. This is actually what they do at Slack. There's this really interesting tech conference here about how they do it by Valera Sakharov. But for us, again, in our constraint, it didn't really work, right? We don't want to spend months building something. And then the option two is right in front of our nose. Why don't we just use the SonarQube API? We already have all the issues in there. They have a great API. We can just query it and get the information. We already pay for it, and we already know how to use it. So we went with that. And then the last point, which is the most interesting one, is how do we visualize this data, right? So at Qonto, it's quite interesting. We use Notion for everything, which is great sometimes, not so great sometimes. Here the problem is, at the time at least, Notion didn't really handle graphs. And even now they handle graphs, but it's still like pretty primitive. And it also would need some extra synchronization between our database and Notion. And we know by experience that sometimes Notion is quite slow and it just didn't really feel right. But then we also have another tool that we use at the company already. It's called Metabase. It's already connected to our database. It's already getting all the information in there. And it's really good at data visualization in general. So if we want to summarize this in one sentence, to build a first prototype, what we want to do is we want to empower each team to be able to visualize and act on the depth they own. To do so, we will leverage the data from SonarQube, format and store it, thanks to our mobile metric service, and display it using dashboards on Metabase. The mobile metric service is a fancy word for a database that have some kind of like REST API in front where we can insert and read data. All right, and just to prove that it's really nothing crazy, there's no like some crazy program we need to build. This is what we've went for. So what we have in blue is what most of you have. You just merge some code to develop, and it just runs Sonar and upload all the data to SonarQube. So this we already have it. That's great. And the thing we need to build is in red, which means we need to create another CI job that is going to fetch the data from the SonarQube using the API, and then format and store this data in our database. And then we need to create some dashboard with Metabase that are just going to read the data from the database and display graphs. And that's really only what it is. So there's really like maybe a couple weeks of work for one engineer, because there's some tools that we need to still understand a bit how they work. But it's really nothing crazy. So you don't have to squint from this. Like, it's just to give you an idea a bit on how we explored, how we wanted to have the dashboards. Because I wanted to have something that's really frictionless, where you can really go from like a big view where you see all the teams and all the depth down to the file, where you can see on this file I have all these issues, and this is how I can fix them. So this was the exploration, and then here I have a couple of screenshots of the first POC. I'm going to go quite fast because there will be a live demo after, where we have what we have at the moment. But so here, this is basically how it looks like. It's used some data, just a subset of the data, so the numbers are not maybe reflecting the actual reality, but this is like good enough. So we have a score of the code base, which is basically -1 for all the issue we have. And then we have a list of all the teams and how they are doing in terms of score. And then we also have a list of all the modules, also themselves have a score, and then a tendency of the whole code base with the graph. And here, what's interesting is that we find again our what we wanted to do, which is we wanted to visualize the part of the code base that don't have any ownership. And as no surprise, we see that actually the part of the code base that don't have any ownership is the one that's doing the worst in terms of depth. So now we can at least visualize it, and because everyone in the team can visualize it, we can also act on it properly. And so this is the global dashboard. Most of the team actually don't really look at that. This is just to have like a global view. And then you can click and you can go through, for instance, your team. And then you have your team score, you have the modules they have, you have the occurrence of each of the rules that they are violating, and you also have a tendency. And then you can drill down even more. So you can go at the module level and at the file level. And the most interesting dashboard as well, after the dashboard of the team, is the one where you can visualize specific rules, right? So one thing that we have quite some issue at Qonto is to track the progress of resolution of one rule, right? So you want to migrate something that's in the whole code base, and you want that each team spend some time to do this in the code they own. But at the time, we couldn't really do that. We had to do this like very manually. We had to like go through like lists of usages of the code and trying to do, Excel sheets and whatnot. And of course, the code is alive, so it moves. And so it was just really a nightmare to track. And now we have this that's real time. Whenever you merge your code to develop, if you fixed an issue, it just appears right away. And here you can see, okay, for this very specific issue, I know that we fixed 15% of them in the code base. So not there yet, but making progress. All right, and then now what we want to do, right? Do we want to release this first POC to all the teams in one go? Probably not, right? We want to test it on a smaller subset of teams. We want to see that we didn't miss anything that was big and we just didn't see. We want to make sure that they know how to use the tool and it works for them. So we gather some feedback from all our stakeholders, so from the engineers, but also for the lead/manager and the staff engineers. And so we gave them a little list of things they had to do with the health board. So for instance, we tell them like, okay, try to find your team's health board and fix one of the issue. And the idea is that that's what most teams would do on the day-to-day, so we can see if they have any friction or any problems. And so once we've done that, we implemented a bit of the feedback they gave us, right? If there was nothing really too big, they really understood how to use it, and they managed to fix some of the debt. And then we logged the rest of the feedback to potentially come back to it later and do it as well. Also, what was interesting is that even though we released the board for a couple teams, it actually started to leak to other teams. So we started to have other teams also looking at it and fixing some debt. So that was like a really good indicator that we were probably on the right track. We also find a name that sticks. I mean, it's a long name, but it works and people like it. So it's called a CFT Health Board, or CFT HP for short. And of course, because a project or initiative is nothing without a definition of success, right? You want to see, did I reach my success? Should I continue on this way? We said 2. We said that after 6 months of releasing the dashboard, we want to have 90% of the CFT reducing their tech debt by 50%. And we set another one that we want to stop having any manual cost for tracking code-based-wide migration, right? We want to stop dealing with CSV and tracking things by hand and just losing a ton of time. All right, adoption. So we saw how we found a solution that was cheap and somewhat easy to implement. We spent a month implementing it. We had a little beta testing time. We implemented some of the improvements from this, and now it was time to release it to every team. And so we released it to every team, but we wanted to be sure that everyone knew this was there. We have 50 engineers, so it's not like we can be on the back of all of them and show them how it works and whatnot. So we wanted to communicate always like really positively around the health board. We didn't want to ping people and be like, oh, please use it, please use it, please use it. We wanted to just have it omnipresent in their day-to-day life. So we created a dedicated channel for it, so people could go on there, they could ask questions, they could get updates on what was new, what we implemented, what we were thinking, participating in discussion and whatnot. And we also have what we call a cockpit, which is just a fancy page, a fancy name for a Notion page where we have all the documentation and all the information about the health board. And we started to communicate quite a bit on it, especially in our weeklies. So we would communicate whatever was changing about it. We were communicating, for instance, the top 3 teams that solved the most issue in the last week. We were sharing wins as well, so whenever a team managed to get rid of like a particular sticky issue in their code base, or if they managed to get like a perfect score. And so what it does is that it reminded everyone that this was existing, and it started some also friendly competition between teams when they saw that some teams were like reducing their score by quite a bit. And then we also listened a lot to feedback. We log again these improvements and ideas to show everyone that this is something we care about and this is something we want to improve, but we also didn't want to spend months on it like straight away creating like 1 million improvements. We also introduced some gamification, so if you manage to finish and completely erase one of the rules from your team code base, then you'll get like a little badge on your dashboard and whatnot. And it does actually work quite a bit with some of the engineers in our team. We iterated also quite a bit on the score. So we saw at the beginning we had a score that was pretty basic, right? It was just going -1 for each of the issues. And it was not really clear, if I have a score of -300, is it good? Is it bad? It was also not super fair because it was easy for, like small teams that have 2 modules that have been just created to have 0, whereas a team that had, existed for the last 7 years and had like 700 issues, it was a lot harder. So we made it a bit more fair with some math, and we also introduced coefficients. So now we have issues that are, more important than others. So if you tackle an issue that have a coefficient of 5, then you improve your score a lot more than if you tackle an issue that has a coefficient of 1, right? You could think about, if you have a detect unit import, it's not that bad compared as if you want to, get rid of an issue that, backend, for instance, want to remove some API or something like that. And then we also did a lot of work on the rules themselves, because now that we could visualize all these rules, we saw that a lot of them maybe didn't really make sense to fix or to have engineers spending time to fix. So we also look at all these rules, had some kind of committee looking at them and understand which one we wanted to actually keep to avoid having too much noise. We also started to involve a lot more the team. At the beginning, I was the only one really working on it and building it. But we really encourage all of our engineers to also write their own rules, for instance. And we also supported them to build around the health board. We'll see in the demo that some of our engineers built awesome blocks around the health board as well. And we also wanted to make it easier for anyone to report very simple issues. And so we introduced like an annotation you can put on any piece of code, and this is going to report it as an issue with this specific ID. So for instance, in the design system, we have a lot of components that at some point are deprecated, and we can just slap an annotation on it, and it's going to report directly this issue in the health board and be visible by the team. All right, so let's look at some results. And so in terms of definition of success, so 90% of the CFT reduced their tech debt by 50%. We actually managed to do it in less than 3 months. So it was a really positive outcome. It was twice as short as we thought it would be. And we completely achieved being able to track migration without doing any sort of manual work. All right, so now it's demo time, which is my favorite time where everything can go wrong. Let's see. So here you can see the global health board as it is today. So it hasn't really changed that much, but we can see here that we have all of our teams, we have their scores, and we also have all the modules. Without much of a surprise, we have the monolith that's still standing at the very top, which is again like a really good visual reminder that we really need to tackle that. We're actually in the process of tackling it. We can see something interesting here. We can see that something happened recently, and we had a bit of an uptick in terms of issues. So maybe there's something that we should look at in here. And we can also filter this board by using our domain, right? So we have 4 domains that have different teams in there, and we can filter it, which is quite nice for our head of mobile, for instance, to have a look in there. And if I remove it, then we see everything. And something we've added recently, when I was talking about different type of debt, we added like a new tab here, because at the moment we are transitioning all of our UI tests through 2 phases. And up until a couple weeks ago, it was not possible to really visualize where we were. And so now we can see that we have all these teams here. So the ones that are in the green, they transition all their UI tests through the 2 phases. The one that have some red and orange means that there's still some work to do. But at least here, this is completely live, and we can see, okay, maybe some team need some help or support to tackle their UI test, because they have a lot more. And we can also see here whenever this is going to be finished, and we can finally do the cleanup. So that's quite nice. And so, as I was mentioning, right, this is maybe a view that the staff engineers or the heads want to use to have a global view, but most of the team actually want to look at the tech debt they own, right? They want to fix whatever they have in their code base. So if I take a look, for instance, at spend management, so I can click on it, and I get to the dashboard. So they have a pretty good score. can see here the badges. So that's like the bit of gamification. Those are like big issue we tackled recently, right? So remove the data binding. We got ready for Android 16 and edge-to-edge. We had over 200 activity to deal with, and then a bunch of other issues. So let me check. Okay, so the UI test, so I was talking about this. So you can also see here in this specific team, they still have 2 tests that they need to transition, and you can see exactly which one they are. And you can see they don't have any flaky tests. We also have problems with, as I guess most of you, tests that are flaky. They are reported in here, and people can fix them then. And this has been added by another engineer that just built on the help port. We also have a part where we can see the dependencies. We had a problem where our dependencies were not updated as often as we wanted to, and it was blocking us quite a bit for some features. And so now each team owns also dependencies, and they have their own dashboard where I can see the one they need to update, right? So here, this team is doing really well, and all the dependencies are up to date, but otherwise they would appear here, something in the available release. Right, and see, here is also the issues. We can see here, it's quite interesting, we have the coefficient, right? So this issue here, stop reporting generic non-fatal errors. You can see that in this team there's 5 occurrences and then a coefficient of 2. So maybe that's the issue at the moment this specific team should look at. And now, if I dive a bit in what I think is the most interesting, so if I go to this one, this issue, for instance. So here, this issue, this team has tackled all of them. But if we remove the focus on this team here, which is going to give us the numbers of the whole on the whole team, we can see that we still have 128 issue to fix for this rule. And if we click on global here, we can see the breakdown by team, right? So yet again, we can see that the problem here, the bottleneck seems to be the modules that don't have any owner. And you can see here by module where most of these instances are. And here is quite interesting. I created this graph quite recently to see teams that are actively working on this issue. So for instance, the one that have a very flat line mean that they probably don't even look at that issue, and maybe we should chat with them and understand why they are not fixing it, or if we can help them support to do so. And if we take another example of an issue that has been done, so for instance, this one has been tackled recently, hopefully, yes. So here we have 100% of issues that are done. Here we see the tendency, and we can see here that we are at 0, right? And this is how it looks like. So this was like a big migration that we had to do to help backend get rid of quite some old code. And this was like the dashboard I was using on the day-to-day to see how things were going and if anyone needed help. Yeah, I don't think I think I showed everything. Here, what's interesting as well is that we have each of the things that are impacting your score, right? So you have the flaky test, the UI test, migration, the dependency, and the issues, and each have a different impact. So for this specific team, for instance, they might want to be working first on their issues because that's what has the biggest impact, and then maybe on the UI test migration. All right, let's go with learnings. So we did learn quite a bit during this project. So in terms of what worked, what has really worked for us here is iteration. So as I mentioned, we really built this first prototype in 1 month, and then we just kept on iterating. We released it like 10 months ago, I think. And then bit by bit, every other month, we were adding a new feature on top. So we really started small. We checked that the value was in there, people were using it, and then we just built slowly on top. Don't underestimate the small features that reduce friction. Oh yeah, I forgot to show this. This is the best part. Sorry, I'm going to try. So if you go to the issues, because one thing I was really worried with this was the friction of looking at your issues and then going back to Android Studio and then looking for the issues. But actually, if you take, for instance, this one, and you have the list of issues in your code in here, you can just click on this little link. All right, so here I have the issue of my team, right? And I have this little button here that says C in Android Studio, and you can just click on it, and it should just point straight away to the right issue, and you should see at some point the squiggly line. Well, maybe it doesn't work. No, but if lint is properly working in Android Studio, you should see that you have this red line, and you can just fix it right away. So that reduces friction by quite a bit, because you don't have to look at the class, look at the line, and then you can just straight up go in there. All right, so don't underestimate the small feature that reduces frictions, like the one I've shown you. This is the one that I hear the most about, even if at the time when I implemented it, I didn't really think much of it, but it's really the one that the engineer really love. One thing I want to stress out as well, I think it works really well at Qonto because we have a really good culture around supporting each other, but try to really keep it positive and avoid blame, because this core system can really become a way for people to, awesome. So try to keep really positive and use the score as an indicator that the team needs support, rather than blame that team not to fix their debt fast enough. Because we always need to have AI in any talk these days, I actually used AI quite a bit. It was really helpful for SonarQube. They have a crazy API documentation that's really hard to read. So it was really a good help to understand what I wanted and how to implement it. I also used it a lot for SQL queries. I had to do a lot of SQL queries for the dashboards. And AI is actually really good at them. You can just say, here is my schema, and here is what I want to visualize. And pretty much always they manage to give you a query that just works, maybe like 95% of the time. So that's really helpful. And then when other people start to have these crazy queries, you can also just ask the AI what's going on in there, which is also really helpful. What we had to adjust quite a bit. So at the beginning, we were making changes to the score like crazy. We were like changing the formulas. We were adding some more coefficients here and there. And we did realize that it was quite annoying for the teams because they saw their code, their score changing quite a bit without seemingly any reason. And teams do actually need to have predictability. So what we are now doing is that we are leaving the calculation of the score as it is in an entire quarter. And then 1 month before the next quarter, we are planning how we are going to calculate the score for the next quarter. So that's where we say, OK, we want to add this other type of debt to the score, or we want to have these rules now from a coefficient of 1 to 3. And then the team also can then visualize what is going to be their new score and act accordingly if they want to. One thing that was quite hard for me at the beginning also is that you really cannot add or implement every request. We got really a ton of requests, and I got quite overwhelmed. But so what I ended up doing is logging this request somewhere to see that I cared and that we were looking at them. And instead, I was encouraging people to just do it themselves and offering my support. And this worked really well. And that's why we have the dependencies as tech debt, and we also have the UI test flakiness at tech debt. It's been implemented by other engineers, and that was awesome to see. What we're still trying to figure out is how to write a good lint rule for the health board. To give you an example, recently, we've had someone writing, they wanted to move most of our tests that are using JUnit 4 to be using JUnit 5, which is great. But what they did is that basically they were reporting one issue per import that was a JUnit 4 import, which meant that once they were done with writing this rule, it added 6,000 issues to the board. And what that meant is that every time you were opening a test, you would just have just a ton of red everywhere, at least in the imports. And so when we sat down and we thought a bit more about it, we realized that what we want to report is not that you're using the wrong import, but that this test file should move to JUnit 5. So instead, we reported one issue per file and offered a quick fix for all the imports. And so this reduced I think the number of issues from 6,000 to something like 500 or something, and it's a lot more easy for engineers to visualize and understand what's going on. Another thing also that we are still trying to figure out is we actually had the inverse effect. So a lot of people really got excited with the health board and started to create a ton of rules, which meant that we started to report like really a lot of issues. Some of them maybe didn't have that much priority, and we didn't want people to really work on it. So we started to have, similar to the quarter, we now also every quarter look at all the new issues that we put at 0 by default, and get some of this issue to 1 for the next quarter, but not all of them at once. Something also interesting that we've seen is that some of the teams are not as focused on the health board as others. And for this, at the moment, we're trying to talk with them and figure out how they use it, if they use it at all, and how we can help them make it work for them. And so in terms of future, we have a ton of ideas, but here I'm just going to present like 3 of them. We want to integrate other dimensions of the depth. There's always more dimension of the depth, and one that's quite interesting, we have an app that's quite large and heavy, would be to add the app size, for instance. So each team could see this is the portion of, this is how many megabytes I'm contributing to the APK, and how can I maybe reduce that impact. We also want to support other stacks at Qonto to integrate the health board. So I didn't really talk that much about it, but the way we build the health board is actually very agnostic. We just really have some kind of project ID, that's the SonarQube project ID, and that's pretty much it. We have a few ways of getting the modules that maybe are a bit specific to Android, but there's really not that much thing that are really Android only. So with a minimum amount of effort, we should be able to use it for any kind of stacks, as long as they use SonarQube, because we use their API. But at Qonto, everyone uses SonarQube, so that should be working. So we are talking already with iOS and web and backend, and to try to help them figure out if this tool also would work for them for what they want to see. Something that would be awesome to reduce even more the friction, right? At the moment, I still find it quite annoying that you have to go to Chrome or Firefox and then look at the issues and then click on them, and then you get to the ID, and then you need to go back to the browser and etc. So what would be awesome is to have our own Android Studio plugin where we could have all the data right there, and you can just tackle depth without even going out of the ID. And so in conclusion, I think what really worked for this project and what I'm taking from this project is that we really used the tooling we already had. Like there was nothing new that we needed really, and this really gave us a lot of edge, because we didn't have to ask for a budget to get a new tool. We didn't have to get to know another tool, and we could also build it quite fast because we knew how to use what we already have. And if you are in a company that's our size or even smaller, you should probably have a tool for everything I described. So you can also really start quite easily. Start small, bring value, validate, and iterate. So that's what I've been talking about most of the time. Really start something small, see if this brings value, see if people use it. Otherwise, go back to the sheet of paper, or try to find another way to tackle the problem. And then once you validate, then iterate. Something that was also quite a bit learning is communicating and listening, of course, but supporting other people to do rather than just do it yourself, because you just become the bottleneck. And then once people just do things, then you get like a lot of new features that works for them, which is awesome. And maybe I'll finish with this. So this is one of the first slides I was showing at the beginning. This is how our depth was doing. And after the release, and to this day, this is how things are going now. So on this note, I'll just finish here. If you have any question, I'll be hanging out over here, and I'm happy to answer any of them. Thank you.